this last lecture is the types of graphs or displays that we use for quantitative, the numerical data. And a couple of terms that we need to understand are outliers, and those are observations that are away from the rest or lie far away from the rest. And when we say the rest, we mean the rest of the data. When we have a cluster, that's going to be just a group of data that's grouped together. And a gap is going to be a large distance between observations. And we'll be looking at these terms here as we go about the chapter and further on, because when we have a gap, that might tell us something meaningful, or a cluster, or an outlier. When we look at quantitative data, we're also going to look at the distributions, kind of the model of the direction that the data falls. So when we look at symmetric, that's this curve right here. Symmetric means the same size, look on the left and the right. Sometimes we call this bell-shaped. When we have bimodal, bi means two modes. We haven't talked about that word yet, but basically it means that you have two peaks. When we say it's skewed right, when we have something that's skewed right, there's a big peak and then it has a tail off to the right. Something like this would be income. Most of us fall in this area, and we have some of those that make a lot of money and they fall to the right. Just opposite of that would be something that we call skewed left, and that has the tail and then the peak. And this might be grades, where we have a lot of high-end grades, and then we have some that fall in this area. And the last is uniform. Uniform is just that. It's all the same. So it almost looks like a rectangle. So notice this is a continuous line. It's not a choppy line on any one of these. It's continuous. That means I have a person in every one of those. And the models that we're going to be concentrating a lot would be the symmetric, and we are going to look at skewed right and skewed left. So in order to look at these models, we need to get the data as in a picture instead of all these numbers just out there. We need to organize them. One way to organize them is in a frequency plot. Frequency is how often. So basically we draw a number line, and we'll just happen to do how many children. So either you have none, 1, 2, 3, and so forth. Notice the numbers are equally spaced. Sometimes this is also called a dot plot. I'm going to use X's today. If I have counted and I had 5 people with no children, there are my 5. Maybe I had 3 that had 1 child, 2 that had 2 children, and 1 that had 3 children. When I look at that, that looks like it is a skewed right model. If I kind of draw this smooth curve over the tops, it's kind of got this shape here. And that's what we'll be looking for. So notice you're looking for the min and the max on the number line. I didn't have anybody with more than 5 children. Really, I didn't have anybody with more than 3. And I use an X. Now sometimes you can use a dot. What you need to make sure is the X's are all the same size with the same spacing. Another way to display quantitative data is in a stem and a leaf plot. This also will work for small sets. Frequency plot you want for small sets of data. You don't want to put a whole bunch of X's on there. It takes too long. We can create what we call back-to-back, and you'll see that in a problem in your textbook. And this is used to compare 2 sets. And what we like about this, just as in the frequency plot, it actually shows data values. So how do we construct a stem and a leaf? Well, given a set of data, we have the stem and we have the leaf. Another piece, 15. Stem is 1, leaf is 5. Stem is 1, leaf is 8. So think of a tree, and off of the stem comes the leaf. So if we take a quick look at this data set that I'm making up, maybe this represents ages. We're going to draw a line. On the left-hand side is the stem, 1, 2, 3. And on the right-hand side is a leaf. But what we need to do is worry about equal spacing and increasing, decreasing order. So when I look at my ones, I had 3. So I'm going to go 10, 15, and 18. There are no commas, and they're equally spaced. In the 2 stem, the leaves are 2, 3, 5, 6, 2, 3, 5, 6. So I can see my data, see the actual values, and I can see that I have more in the 2 stem than I do in the 1 stem, and so forth. 38, I would actually put 3/8. Now when I draw this smooth curve, this looks somewhat symmetric. These two are lower, this one's the highest. So it looks like it's symmetric. Now with both of these, the stem and leaf, and the frequency plot, this is for discrete data. You can plot decimal points, but if it's continuous, I would have so many lines going out, I wouldn't be able to show all of those lines. So if we go back here, let's go ahead and label this frequency plot right here. This is also for discrete data, countable data. Notice I never had a number between 0 and 1. I just jumped from one to the other. So that's how you would display quantitative discrete data.